Now that we know how to determine absolute configurations, let's tackle a few practice problems to prepare for how you might have to apply this concept on your exams and determine the relationships between molecules. This video will not focus on how to determine absolute configurations, but how to interpret them. So if you would like to learn the CIP rules, I would recommend rewatching our previous video on understanding absolute configurations. You can follow along with these practice problems on page 206 of your Volhart and Shore Organic Chemistry textbook. Here's our first set of molecules. They have identical substituents and are both chiral, so let's determine their absolute configurations to determine their relationship. After applying the CIP rules, we find that the configurations of both these molecules are R. Thus, they are identical. They have the same substituents and absolute configuration. You can verify this by building each of them with the modeling kit. This next pair of molecules also features the same substituents and are both chiral, so let's determine their absolute configurations again. The molecule on the left is R while the one on the right is S. Remember to rotate the molecule so that the lowest priority substituent is pointing away from you. Since these molecules have the same substituents but opposite absolute configurations, they are enantiomers. This applies even if the molecule has multiple stereocenters. When two enantiomers such as these are present in equal amounts in a mixture, we refer to the mixture as being racemic. Racemic mixtures have no net optical activity because the enantiomers that comprise them have equal and opposite optical activity. In this example, there are two stereocenters in each molecule. Determine the absolute configurations of all four of them. Remember that if you have identical substituents, refer to the second atoms from the stereocenter to determine their priority. Since, after rotating the molecules to face the same direction, each stereocenter has the same absolute configurations, these are identical molecules. However, even though this is not a racemic mixture, it has no optical activity. Since there is a plane of symmetry in these molecules, they are considered meso compounds and thus have no optical activity. You can picture why meso compounds have this characteristic because each of this molecule's stereocenters are essentially enantiomers of the other. They therefore have equal and opposite optical activities that result in a net of 0. For this example, there are once again two stereocenters per molecule. These molecules are diastereomers of the other, meaning that they have the same substituents but differ in absolute configuration at one stereocenter. An easy way to identify a pair of diastereomers without finding the absolute configurations of all their individual stereocenters is to see if the stereochemistry of one or more pairs of substituents around the same stereocenter is switched by comparing the two molecules. In this case, the hydrogen and chlorine are switched between them. What would happen if the pairs of substituents on the other stereocenter were also switched? Then these two molecules would be enantiomers, not diastereomers. So, just remember that in order for two molecules to be diastereomers, they need to have opposite absolute configurations or opposite pairs of substituents at one or more stereocenters, but not all of them. Now, for our final example. Note that the stereocenters that correspond with each other, that is, that have identical substituents, are not in the same position between the molecules when you compare the configurations. As you can see, in this case it doesn't really matter because they all have the same absolute configuration, but do keep that in mind for other problems. You can see that they have the same absolute configurations. Thus, we can conclude that these are identical molecules. This table summarizes all the key concepts that we went over in this video. Just remember, if you're ever confused about which atoms to compare to the other or how to rotate stereocenters, you can always use your 3D modeling kit so you're comfortable doing without. Thanks for watching. I hope this video was helpful.